In the beginning, there was nothing. No space, no time, no matter. Then, in an instant, everything that has ever been or ever will be exploded into existence. This is the story of the universe, our story, from the very first moment. Imagine a point infinitely small, infinitely hot, infinitely dense, a singularity. This was the universe before the Big Bang. What was before that? We don't know. Science can't yet see past that wall of infinite energy. But then, about 13.8 billion years ago, it happened. The Big Bang. This wasn't an explosion in space, but an explosion of space itself. In a fraction of a second, the universe inflated, expanding faster than the speed of light, stretching from a subatomic size to something bigger than a galaxy. This mind-boggling expansion is known as cosmic inflation. As it slowed, it left behind a searingly hot, dense soup of fundamental particles and energy. The stage was set. In the first microseconds, temperatures were trillions of degrees, 100,000 times hotter than the center of our sun. It was a chaotic swirl of energy and matter, where particles like quarks and electrons popped in and out of existence in a frantic dance. The fundamental forces that govern everything we know began to separate from a single, unified force. First gravity, then the strong nuclear force, and finally, the weak force and electromagnetism parted ways. As this primal chaos subsided, something incredible happened. Quarks, the building blocks of protons and neutrons, began to stick together. The universe was starting to forge the first stable pieces of matter. Protons and neutrons, the very heart of every atom, were born from this cosmic furnace. As the universe continued its relentless expansion, it began to cool. This cooling was the key to the next great chapter. Just 3 minutes after the Big Bang, the universe was cool enough for protons and neutrons to start combining. This process, called Big Bang nucleosynthesis, was like a cosmic assembly line. For about 20 minutes, the universe was busy forging the first atomic nuclide. Mostly hydrogen, the simplest element, was formed. But a significant amount of helium was also created, along with tiny traces of lithium. These first three elements were the raw ingredients, the seeds from which every star, every planet, and every living thing would eventually grow. The universe's elemental pantry was stocked, ready for the next phase of cosmic creation. For the next 380,000 years, the universe was an opaque, foggy place. It was filled with a dense, hot plasma of protons, neutrons, and electrons, a cosmic soup so thick that light couldn't travel through it. Photons, the particles of light, were constantly scattering off free-flying electrons. Trapped in a cosmic pinball machine, the universe was glowing, but it was impossible to see through this primordial fog. But as expansion continued, the universe cooled further, reaching a critical threshold. It became cool enough for electrons to be captured by atomic nuclei, forming the first stable, neutral atoms. Suddenly, with the electrons locked in place, the photons were set free. Light could finally travel unimpeded across the cosmos. This first light, released all at once, is still traveling through the universe today. We can see it in every direction we look, stretched into microwaves by the expansion of space. It's the cosmic microwave background, the oldest light in the universe, an afterglow of creation itself. After the light was freed, the universe entered a period known as the Cosmic Dark Ages. It was a vast, dark, and relatively boring expanse of hydrogen and helium gas. For hundreds of millions of years, there were no stars to light up the night. But gravity, the silent architect of the cosmos, was patiently at work. Ever so slowly, it began to pull the gases together. Tiny fluctuations in the density of the early universe became the seeds of cosmic structure. Gravity amplified these differences, drawing more and more matter into clumps. As these clouds of gas grew denser, their cores became hotter and hotter. Eventually, in the heart of the densest clouds, the pressure and temperature became so extreme that nuclear fusion ignited. The first stars blinked into existence, piercing the cosmic darkness. These were not like the stars we see today. They were giants, hundreds of times more massive than our sun, burning incredibly hot and bright, and living short, violent lives. In their fiery core, they forged heavier elements that the Big Bang couldn't create. Carbon, oxygen, nitrogen, iron, the very ingredients for planets, and for life. With the birth of the first stars, the universe was lit up once more. And where there were stars, gravity continued its work, pulling them together into vast collections. The first galaxies began to form. These were small, irregular galaxies that constantly collided and merged, growing larger and more structured over billions of years. Stars organized themselves into the beautiful spiral arms and elliptical shapes we see today. But gravity's influence didn't stop there. Galaxies themselves were pulled together into clusters, and clusters were drawn into even larger structures called superclusters. All of this is woven into a gigantic, intricate pattern known as the cosmic web, a vast network of filaments and voids that makes up the large-scale structure of the universe. Over billions of years, in one of these developing galaxies, a beautiful spiral we now call the Milky Way began to take shape, and our own cosmic neighborhood was starting to form. Billions of years passed. In a quiet, unremarkable spiral arm of the Milky Way, a cloud of gas and dust left over from a previous generation of stars began to collapse under its own gravity. At its center, a new star ignited our sun. The remaining material swirled around it, forming a disk of rock and gas. Clumps of dust stuck together, growing into pebbles, then boulders, then planetesimals, and finally, planets. Among them, at just the right distance from the sun, a small, rocky world formed. It was a world of fire and rock, bombarded by asteroids, with a toxic atmosphere. But it had something special: liquid water. This was Earth. Here, on this small blue planet, in this ordinary corner of an ordinary galaxy, the stage was set for the most remarkable chapter of all. Billions of years after the Big Bang, life would arise. Simple, single-celled organisms would eventually evolve into complex creatures who could walk, think, and dream. Creatures who would one day build telescopes, look up at the stars, and ask the ultimate question: where did all of this come from? Today, the story continues. Our telescopes gaze into the deepest reaches of space and back in time, piecing together this incredible journey. But we've also discovered new mysteries. We've learned that the expansion of the universe isn't slowing down as we'd expect. It's accelerating. Galaxies are flying apart from each other faster and faster, driven by a mysterious, repulsive force we call dark energy. It seems to make up nearly 70% of the entire universe, yet we have no idea what it is. Along with dark matter, the invisible substance that holds galaxies together, it means that about 95% of our universe is made of things we can't unsee and don't understand. From a tiny point of unimaginable energy to a vast cosmos filled with galaxies, stars, planets, and us. The Big Bang is not just the beginning of the universe. It is the beginning of our story. The beginning of every story. And as the universe continues its endless expansion, driven by forces we are only just beginning to grasp, one thing is certain: the story is far from over. Thank you for joining us on this journey through time. If you are as fascinated by this story as we are, don't forget to like this video, subscribe to our channel, and hit the notification bell so you don't miss our next exploration into the wonders of the cosmos.